Hello everyone and welcome to ScienceGem, your go-to channel for clear step-by-step walkthroughs of GCSE science exam papers. Whether you're aiming for top grades or just trying to boost your confidence, I'm here to help you break down the questions, understand the mark schemes and learn how to answer like a pro. So let's get into it. Today's walkthrough is Combined Science Trilogy. It's Chemistry Paper 1 Higher and it's 2023. This question is about carbon dioxide. Carbon dioxide is soluble in water and forms an acidic solution. Which ion makes the solution acidic? It's your hydrogen ions, or you can just say H+. Name an indicator that could be used to test if the solution is acidic. Give the result of the test. So the indicator is universal indicator. And the result would be it's acidic, so you would see the color red. You can also say litmus, result would be red, or you can say methyl orange and the result would be red. Figure 1 shows the mass of carbon dioxide that will dissolve in 1 decimeter cubed of water at different temperatures. How does the solubility of carbon dioxide change as the temperature of the water increases? Okay, so you can see temperature of the water, the lines going down, mass of CO2 in grams dissolved in 1 decimeter cubed of water. Okay, so you can see that mass is going down, so the solubility is decreasing. Question 1.4. So how does the pH of the solution change as the temperature of the water increases? So tick one box. pH of the solution decreasing means that there's more H+ ions. pH of the solution does not change, it stays the same. Or pH of the solution increases. So if the pH of the solution increases, you have a greater concentration of OH- ions. So it says use figure 1. So you use that graph, and pH of the solution should increase as the temperature increases. Calcium carbonate reacts with hydrochloric acid to produce carbon dioxide. The equation for the reaction is as follows: calcium carbonate, 2HCl, calcium chloride, CO2 and water. What is the state symbol X in the equation? So S is solid, aqueous, something dissolved in water. Calcium chloride is a salt, it's in solution. Carbon dioxide, you should all know it's a gas. Water, X, is a liquid. Figure 1.6. Figure 2 shows equipment a student used for an investigation. They've only labelled the gas syringe, so this is a measuring cylinder. This is a conical flask. And this is a top pan balance. The student investigated the volume of carbon dioxide produced when different masses of calcium carbonate react with hydrochloric acid. Describe a method the student could use. Okay, so we are looking at the volume of CO2 being produced when we have different masses of calcium carbonate. Okay, so measure mass of calcium carbonate. How? Use a top pan balance. Always go back and look at your diagram. We've got a conical flask, so we will add calcium carbonate into a conical flask. And then the reaction is between hydrochloric acid. So now I take hydrochloric acid and I measure it using a measuring cylinder. So measure volume of HCl using a measuring cylinder. Then you add this hydrochloric acid to the conical flask. And then if you look back at the diagram, you should see a gas syringe which is attached to a delivery tube. So immediately, so straight after this, place the bung or the stopper in the flask. Record the volume of CO2 produced in the gas syringe, and obviously you record that in your table, and then you will repeat that. So if you go back, it says when different masses of calcium carbonate react. So repeat with different masses of calcium carbonate. And that is sufficient for you to attain 6 out of 6. So it's a 6 mark, and again, like I've said in my previous videos, you are allowed to write in bullet points. It just allows your answer to be more concise. Question 2. So remember, your chemistry paper will contain 20% maths. Okay, so we're moving on to the maths questions. Lithium hydroxide, which is an alkali, reacts with sulfuric acid to produce lithium sulfate, which is a salt, and we produce water. So what type of reaction is this? It's a neutralization reaction. Calculate the relative formula mass of sulfuric acid. Relative atomic masses are given. So we do, I've got 2 hydrogen atoms. Relative atomic mass is 1. I will add on sulfur, 32. I will add on 16 times 4 because I've got 4 oxygen atoms. And if you put those numbers into a calculator, you should get 98. It's 2 marks. 2.3, calculate the percentage by mass of oxygen in lithium sulfate. So basically the percentage of oxygen in this compound here. Give your answer to 2 sig fig, and it's out of 4 marks. So let's work out the almost formula mass of O4. So oxygen is 16 times 4. That should give me 64. Then I take 64 and I divide that by the relative formula mass of the entire compound. That's 110. Multiply that by 100. So that's 1 mark. That's my second mark. Whack those numbers into a calculator. And you get 58.1818181. Okay, so that's your third mark. And then 2 significant figures, 58%. A solution of lithium sulfate contains 0.3 gram of lithium sulfate in 25 centimeter cubed. Calculate the concentration of lithium sulfate in grams per decimeter cubed. So centimeter cubed, I need to convert into decimeter cubed first. So in 1 dm cubed, you have 1,000 centimeter cubed. So 25 centimeter cubed. So centimeters to dm cubed, I divide by 1,000. Okay, so 25, divide that by 1,000, I will get 0.025 dm cubed. And then, if you don't know how to do it, or you don't remember the formula, just look at the units. So you can see G, which is mass, dm cubed over volume should give you concentration. Okay, so mass is 0.3 grams. My volume in dm cubed, there it is, 0.025. If you put those numbers into your calculator, you should get 12 grams per dm cubed. And the units are already there. It's the units that have allowed me to kind of work out what the formula is. So if you don't remember the formula for concentration, pay close attention to the units that have been given to you. Question 3. Sodium is in group 1. Sodium reacts with oxygen. Balance the equation for this reaction. So 2 oxygens there, so I'm going to put 2 there. That gives me 4Na. Explain what happens to sodium atoms and to oxygen atoms when sodium reacts with oxygen to produce sodium oxide. Look at the formula. Okay, so it's a bonding question, so C2, and metal, non-metal, so I know it's ionic bonding. So now I'm going to write about electrons and how this bonding occurs. So we know metals lose electrons. So sodium atom, you must say atom and not just sodium loses 1 electron. So sodium atom loses 1 electron. Oxygen is in group 6. It needs 2 electrons. So oxygen gains, so again, see, even I forgot, oxygen atom gains 2 electrons, but sodium is only giving 1, so this means that there must be 2 sodium atoms. So 2 sodium atoms to 1 oxygen atom. We can say each sodium atom transfers 1 electron each to oxygen atom, which then obviously gives you 2 sodium atoms. And then your 4th bullet point is where you must write down the charge. You end up with Na+, and you end up with O2-. These are the ions that will form. 4 marks. So you can see you don't need to write a lot. Just because you have been given so many lines, AQA have a tendency to do that, it doesn't mean you have to fill out every single line. Sodium burns in a gas jar of oxygen. There's your equipment. Give 2 observations seen during the reaction. Always remember, observations are things that you would see. So sodium, sometimes even when you place it in water, you will see a yellow flame. But obviously here it's oxygen gas. You can still well, you will still see a yellow flame. And you know, you're burning it with oxygen, so you can say the sodium melts, or a white powder or a solid forms, which is your sodium oxide. Describe two differences in the observations if potassium is used instead of sodium. So we know potassium is more reactive than sodium, so the reaction should be more vigorous. So just like how potassium, when reacting with water, gives you a lilac flame, you still end up with a lilac flame when potassium burns in oxygen. So lilac flame. And like I said, potassium reacts more vigorously, so you can say it burns faster. Or you can say this is a more vigorous reaction. That should get you 2 marks. Group 7 elements are known as the halogens. All atoms of group 7 elements contain protons, neutrons and electrons. What is the order of discovery of the proton, electron, neutron? So if you think back to C1, structure of the atom and the history of the atom, we know that the electron was discovered first. Okay, so we can get rid of this one, we can get rid of that one. And we know that the neutron was discovered last by James Chadwick. I can see neutron here. So no, it's not that one. It must be the second one. So electrons were discovered first, followed by the proton, and then followed by the neutron. I've got the mass of a proton, I've got a mass of an electron. Calculate how many times heavier a proton is than an electron. So 1.673 times 10 to the power minus 27. So how many times? Divide 9.109 times 10 to the power minus 31. Put that into your calculator, you should get 1837. A bromine atom can be represented as this. That's your mass number, that's your proton number. What is the number of neutrons? So you know, to calculate neutrons, it's mass number, subtract proton number. So 81 minus 85 is 35 is 46. What is the number of electrons in a bromide ion? Bromine atom has 35 electrons. Bromine is a halogen, it's in group 7, so it would like another electron. So it gains 1 electron to become a bromide ion. How many electrons now? 36. Chlorine has 2 isotopes. Table 2 shows the percentage abundance of 2 isotopes of chlorine. Calculate the relative atomic mass. Okay, so there is an equation for this. Okay, so what you do is look at the first isotope, take the mass number, 35. What's the percentage of this on Earth? 75.7. Close the bracket. Add on the second isotope. My mass number is 37. My percentage abundance is 24.23. Divide all of that by 100, which is, when you add these two values up, you get 100. But always remember, just to make your life easier, don't worry too much about adding these two numbers up. It is always divide by 100. So put those into your calculator. You should get 35.4846, 2 decimal places. So it's 35.48. Figure 4 shows the outer shells of one molecule of chlorine. Complete the dot and cross diagram to show the electrons in the outer shell. So chlorine, chlorine, non-metal, non-metal. So we know it's covalent bonding. It's a halogen. It's in group 7. So there's 7 electrons on the outer shell. Make sure one's dot, one's cross. 6. And when you count the outer shell, you should end up with 8. So 7, 8, 7, 8 for 2 marks. During electrolysis, ions are discharged at the electrodes to produce elements. Here, ions become atoms. A student investigates the electrolysis of sodium chloride. Why does solid sodium chloride not conduct electricity? It's because the ions are fixed here. They can't move, which means they cannot conduct. So ions are not free to move. Sodium chloride solution conducts electricity. Complete the sentence. Sodium chloride also conducts electricity when molten. So these are the only 2 conditions that are required for an ionic compound to conduct electricity. Ionic compound will not conduct electricity when it's a solid, but when you dissolve it in water, it will conduct electricity. When you melt it in its molten state, it will conduct electricity. Here's your setup. Inert means unreactive. Suggest an element that could be used to make the inert electrodes. Carbon, or you can say graphite. Complete the half equation for the production of chlorine gas at the positive electrode. So chlorine gas is a product after the arrow, so I'm going to put Cl2 there. Right, each chloride ion, okay, becomes an atom. There's no charge here. So that means chlorine, each chlorine ion, it's losing an electron, E minus. Okay, if I've got 2 chlorine atoms here, that means I must have 2 chlorine ions. So now the charge here is 2 minus. I need to make that 2 minus, so I'll put a large 2 at the front of electrons. Sodium chloride solution has a pH of 7. During the electrolysis of sodium chloride solution, hydrogen gas is produced at the negative electrode. The pH of the solution increases. Explain why. So just a quick recap. Remember the word panic. Positive anode. Negative is cathode. So if I have NaCl, sodium chloride solution, hydrogen gas is produced at the cathode. H plus ions move towards the cathode, which is negative. And the pH increases. Explain why. So it's solution, which means there must be water molecules present. So water breaks down to produce H plus and OH minus ions. And you can also write that as an equation if you wanted to. H plus plus OH minus. Okay, these H plus ions are attracted to the cathode, where H plus ions are reduced, which means gain of 1 electron. And the reason why this is happening is hydrogen, if you look at the reactivity series, it's less reactive than sodium. Hydrogen is less reactive than sodium. So there is a decrease in H plus ions, or you can say there is an increase in OH minus ions, one or the other. And obviously that will then explain the pH increasing. Can't decrease because I've got less concentration of H plus ions. That should get you 4 marks for this question. Acids react with some metals to produce soluble salts. So C4. Chemical changes. A student adds magnesium to hydrochloric acid until no more acid reacts and excess magnesium remains. The equation for the reaction is this. Describe how solid magnesium chloride is obtained from the reaction mixture. So I've got excess magnesium remaining. So I need to filter that. So I filter first, and then I can say the evaporation of water from magnesium chloride. So the magnesium chloride is obviously going in an evaporating dish or basin, and the water, once you start heating it, the water will evaporate. A reaction between magnesium and hydrochloric acid is a redox reaction. Explain what happens to the magnesium atoms in this reaction. So redox reaction is where there's reduction happening and oxidation. So remember the word oil rig. Oxidation is loss of electrons, reduction is gain of electrons. So the question is saying just focus on magnesium atoms. So here's magnesium. Okay, it's on its own, it's an atom. There's no charge, 0 charge. Ignore that, there's no Mg there. Ignore that, there's no Mg there. Here, MgCl2. This is an ionic compound, which means that there's ions here. Magnesium is in group 2, so Mg2 plus exists. Chlorine is a halogen, it's in group 7. Each chlorine ion there is Cl minus, and I've got 2 there. Overall, that's 2 minus, that cancels out the 2 plus. So what is happening to the magnesium atoms in this reaction? 0 to plus 2 means that magnesium has lost the 2 electrons in its outer shell. So Mg, so electrons are lost here. So we say magnesium is oxidized because 2 electrons are lost. Because 2 electrons are lost. .3, it's C3, quantitative chemistry. 0.72 grams of magnesium is added to 100 centimeter cubed of hydrochloric acid. The hydrochloric acid is in excess, more than enough. Calculate the concentration of magnesium solution produced in grams per dm cubed. So concentration equation is mass over volume. Okay, that gives me concentration. But obviously with MgCl2, I don't have the mass. Okay, so the very first thing you do is work out the moles for the reactant that has been given to you, which is that. So I'm just going to write out the equation again. Mg plus 2HCl, MgCl2 plus H2. Right, just like before, I want you to cross out any substances here that we are not interested in. The question talks about magnesium, and then it says calculate the concentration of magnesium chloride. Not interested in that, not interested in H2. So let's work out the moles of Mg. So mass, what am I doing next? Mr or Ar, and then moles. So do the scaffolding like that. So magnesium, my mass is 0.72. I don't have the mass for that. Mr or Ar in this case, relative atomic mass, that's 24. Moles is mass divided by Ar in this case, so that is 0.72. Divide that by 24, I get 0.03 moles. Here my relative formula mass is 95. I can't work out the moles because I don't have the mass, so question mark. Now go to the equation and you can see, look at what numbers are at the front. No number means 1. So the ratio is 1 to 1. So 1 mole of magnesium is reacting to form 1 mole of MgCl2. There's no number there, that means 1. So it's a 1 to 1 ratio. So 1 mole of Mg produces 1 mole of MgCl2. For magnesium, I have 0.03 moles. It's a 1 to 1 ratio. So it must be the same on the other side. So the moles here is 0.03. So if I have moles of MgCl2, and if I go back to this equation, mass over Mr, so I've got 0.03 moles, my Mr is 95, mass is what I'm trying to work out. So if I multiply these two numbers together, rearrange, that should give me my mass. So 0.03 times 95 is 2.85 grams of MgCl2. So I've got my mass. Yeah. So I've got my mass, which is this bit here. Volume, okay, right. They've given me 100 centimeter cubed. 100 over 1,000 should get me decimeter cubed. So that's 0.1 dm cubed. Now I can work out concentration, which is 2.85. Divide that by 0.1. That should give me 28.5 grams per dm cubed. 28.5. Put your final answer on that final line. So quite a considerable amount of working out, hence why the question is 6 marks. Question 7. Which pair of substances both contain atoms in hexagonal rings? Well, we know it's not diamond. Silica, no. So it's fullerenes and graphene. Graphene is a single sheet. If it's rolled up in a cylindrical shape, you end up with the fullerene, so both contain hexagonal rings. Explain why the structure of copper allows the conduction of thermal energy. It's a metal. This question could contain the name of any metal. Your answer would be the same. It's a metal, so I have delocalized electrons, which move through the structure. And because it's energy and not electricity, you need to be referring to energy. And as they're moving through the structure, they transfer energy. explain why copper oxide has a high melting point. Ionic bonding. This is to do with electrostatic forces of attraction between oppositely charged ions. So strong forces of attraction between oppositely charged ions. In this case it's copper 2 plus and O2 minus, and a large amount of energy is needed to break these forces of attraction, hence why copper oxide has a high melting point. So large amounts of energy is needed to break the strong forces or bonds. And final question, explain why water has a low melting point. Water is a simple covalent molecule, just like carbon dioxide, just like methane. So if water gets replaced by CO2 or methane, your answer is the same. So first bullet point, it's a small molecule, or you can say it's a simple covalent molecule. So 1 mark. Weak intermolecular forces. So if I have H2O and another H2O and another H2O and so on, one water molecule has weak forces in between other molecules. So weak intermolecular forces exist. And little energy is required or needed to break or overcome these forces. Hope you found this walkthrough useful. Hope to see you soon with another video. Thank you.